Hello friends, welcome back. So myself Sanjay Kumar Adhikari, and today I'm going to discuss about this embedded programming concept. And please subscribe to YouTube channel Embedkari for further discussion on embedded systems. I recommend to use laptop or a PC with headphone or at least tablet for watching related YouTube video. If you find something missing, please provide feedback in comment box so that I can take corrective action. Key takeaway from today's discussion is Motorola S-record, AVI application, binary interface and executable linker format concept with experiments. And you will realize by end of this session that these are very much important in for in perspective of this embedded system programming. Although these concepts are in desktop also, but desktop when you are writing mostly desktop application means you are writing for this sometime Windows based system or any other desktop system. You are not bothered about kind of resources. There is no resource constraint in terms of memory and all that. So if you are going to design an embedded system, then memory becomes very important, whether it is a program memory or data memory and optimization, or many times like you have the control of the complete program, especially if you are writing for monolithic program, or whether you are low level programming. So definitely these things you must know. So these are very important concepts. So you may find I will quickly go through this Motorola S-record because purpose is not just to visit this wiki information. You can always I provide this kind of link, but because the history of this what today's discussion that somewhere it began with this concept, so that will help in understanding. That's why I'm going to that one. So how Motorola S-record, if you see the .s file looks like, you will find if .s file, if somewhere some application in the 8-bit, or here you will find it is being used in 8-bit, 16-bit, and some color coding is done in this record type, this byte count, address, data, checksum. So here if you see in the beginning as 0, so this is the record type, and then number of counts, then address, then this is the color coding of the data, and at the end of the this there is a checksum. So this was beneficial, especially for flash programming, because that time in the EEPROM and all that, you don't have sometime in the target itself the memory which any other memory which you can use for flash programming kind of algorithms these days, like target, you may download the algorithm there, the fast way of programming, and technology is also different flash, so block by block you can do that. But at that time, if you don't have that memory in the target, at the same time that you have slow communication between laptop and your EEPROM device programmer. So that's why line by line this is there, and at the end of this recording you will find like as record you will find this, for example, why this type is required. You can see like S0 is the starting header kind of. If some sort of version, any information you have to provide, you can use this particular record. This S1 is completely data. So in fact, in that, if you read that EEPROM, you will find the data only. This information in mainly other information record and everything is for programmer. And if you are using any loader for loading the program, downloading the program or executing the program, then this is used for as a start address for the program counter in the beginning if you are debugging. So that's why this is the one of the Motorola S-record kind of concept. Let me go back to our ELF. Okay. The hex file you will have completely data whatever you have to program. So this was for 8-bit 16-bit microcontroller, and in that I forgot to mention this S1 16-bit address. So here the complete detail you can find there, but the meaning of whatever I told. For example, S9, that record contains that starting execution address and all that. Another thing here, now with this latest 32-bit or advanced microcontrollers or microprocessors, you need debugger also, and something for the debugger you need a lot of information. So that is one thing. Apart from that, the one of the AVI interface which was you will see from that Unix from the Unix time, this AVI application application binary interface. So what is this? Let's try to understand that. You might be knowing API, that is application program interface, is the communication mechanism between two software components at HLL, high level language. Means C, for example, it can be in the within language module also. It can be from generally from application to operating system. So you have operating system and you have the API and application program interface. You use those API kind of these kind of things. So similarly, at low level, at binary level, there should be some interface between objects. That suppose one object is calling the another module, then there should be some way calling convention, how that parameter will be passed, and those kind of things should be there. Okay, and all kind of register related information, exceptional handling information. There are different API like exceptional handling API, debug API, and also this executable linker format and dwarf for debugging purpose, debug with arbitrary record format. These things are there. Okay, so I have for these also I have provided, although these are all I told you initially it was from the system 5 based ABI Linux based. So but you can find like I have provided link to ARM specific, AVR specific AVI also, and you can find other AVI link by doing Google. So that's different thing if you want to look into particular AVI. So what I am going to discuss today, that most important aspect of this application binary interface, that is the executable and linker format. So by default you get the ELF generated by your build system. Okay, build system I already explained in my Linux this discussion. So which is this one of the most important aspect anyway, that sorry, the ARM ELF link provides detail of ARM architecture. This link also I have provided. If you are specific to ARM ELF, you want to look into that PDF, go through that. ARM, so ARM Real View and this Keel ARM compiler, they provide basically another AXF format they call, so maybe ARM executable format, almost somewhat similar to that. And ELF is very much acceptable in the industry, whether you go for PowerPC, ARM, whether you go for MIPS, any platform. Okay, So, by the way, if ALF is having so much of information, it is having all that calling convention information, it is having debug information related to source code. So, can we create a project from the ALF file itself? Yes, we can create. So, there are Eclipse-based ID like code variable ID and other ID. They have a feature of import ALF file that gives the complete information of this ALF. So if you provide path of the source files, map the path of the source file used to generate it. Basically, you have to just map the path. Otherwise, that source file path will be there. If build system is somewhere different, then you have to just map. Suppose if that build system is in your network, another machine, so you have to map that to your existing folder. Other then you should be able to browse or source code label debugging you can do if you have debugger have the information of that. So you may use readelf or obj dump utility to read the ALF file. I have taken case study from AVR, whatever we have seen this at Mega 328, and also there's Arduino board based and ARM executable from one of the advanced ARM i.MX board. So in this case, you will see that here, let it go through this first command, and what it is doing here, just a moment. So you can note that like it is using one command and within that format, or I can show you right now here. So let me go through this, and from this particular window, so let's say if this is the command I am using, readelf, and this first immediately it is showing this these values. You can see this target and all that. Same thing it will show here. It will highlight. If you will see that here. So it is highlighting. This is the ARM for ARM file. This is the Little Indian. Okay. Then this is the system B based this ABI, and going down lot of other information. Okay, which we will discuss later, and it gives like BSS test data, different sections, that also we'll discuss just after this. And another one, now you will see that another command it will use, that it will use for this thing, ATML. You see the ATML ABR, okay, and 8-bit, then Little Indian, and then Unix system maybe, and it is going down, then it will show you that the section, text, data, and those kind of sections it is showing. Okay, so again it will also have a lot of information. So another case study too, that ALF from Intel or RISC-V executable in Ubuntu system. Okay, earlier this one was in Windows and using the Cygwin, older one. This one is in the Ubuntu system. So Ubuntu, I have like this particular is showing for AMD x86. So same thing, processor and Little Indian, same data it is showing. After that, it will use the command for RISC-V, and RISC-V, you will notice that whatever command it use, that is actually different from what we are using. So here also RISC-V, Little Indian, and this system B, Unix system B, and so similar lot of information. So that this thing I will show you right now here, that what is the different command I'm talking about. Let me log in into this. So here, if I look into this, I have this file, I will just go through only RISC pipe based. Okay, so if I use simple readelf, let's say if I use simple readelf, so it will take that from my path, and that readelf utility is basically whatever is with my this system Ubuntu system cross tool chain, and this gives here unknown machine and other information you will find intact. Why it is giving unknown? Let me show you the readelf. uh, so readelf, and if I see version of this readelf should work good. This let me double time. That's okay. What's the issue here? Read yes, or version. Yeah, this is giving. And another thing, I have another utility here that you will see tab. If I use this readelf, so that I need to use because current directory I'm using, it will not take from that path, so I have to use this current directory. So you see the difference here. This is basically for Ubuntu 2. This version, and this is the latest one. So this I have taken from RISC pipe bin utils. So that's why if I run this particular utility, so you will realize that it basically identified the code was there, but in this particular case it has taken care that particular RISC pipe corresponding to the code from the L file. That is that anything. And another, you can see again the same lot of data there. Okay, so we will discuss these things one by one. Let me come back to that discussion. So from that basically we can fetch important information from the L file only. Means we need just L file. If somebody provide you L file, and or sometime if you need the target information from someone, you simply ask for L file, and using the readelf utility you should be able to decode everything. So right now I have some readelf, and this DAS A was providing all those kind of target processor name we have seen, and what other information it will provide. It will provide program loader related information. For example, in our S-record case, program loader was using only program counter. Here information you might have observed, like many places written dot text. Those are the sections, or in Intel terminology we will call segment. Okay, so this segment, then this segment actually this is the read only, and many times you will observe segment fault kind of problem in your system. So if you are using Intel machine, so that segment fault in older machine where that address constraint was there, so that is each section comes with some attributes. Okay, so those attributes, for example, this is the read only. If somebody try to write to that, or so violate that, so those kind of things can generate this segment fault kind of. And secondly, another important, only one is program, and second this data, and the data what you need initialized global table variables, whatever statically allocated, means that dynamically these are not at runtime, so initially compiler allocated. And similarly, there is called BSS, basic service set, that is uninitialized is required. So why BSS is required? Because if I put everything is only in this data, so what will happen? Let's say you have certain a big table where you don't want to initialize it, and but if you put it in the data, you have to put some data into that, let's say 0 0 or even uninitialized, so it will unnecessarily take space of the executable file. You know that this is let's say 100 byte information, so you can, if you are not going to initialize it, uninitialized, then you can simply put, okay, this data I don't care, this is the 100 byte from this location. So I mean this 100 byte you need for that particular variable, so that may that way it will save that space of this your disk. And the second, raw data means if somebody something is defined as a constant or a string, that is the read only data. And heap, that is the free memory from where it will allocate that dynamic memory at runtime. We use malloc or any other purpose. And stack related information it will have, that is so finally stack will can go to the down heap, and this memory will, this can vary, and initialized data it is like that only, and raw data and tags. So overall picture is this. Okay, so that's why now onwards, if you read any read elf file using the read elf utility, so you will have that understanding of certain things like tags, what is, and also this will be useful when you will be linking. So in the linker you can see that if there is a linker file, so you can see that how these are being linked. So very useful information from the build perspective as well. And anyway, like loader or debugger can use these data means which has to be initialized by 0 sometime BSS that later that debugger can initialize BSS 0, because it has the idea of the basic purpose is solved of saving the space, but later it can initialize that area to 0, something like that. Okay, so that's all. Thanks for your time, and I will continue to discuss this in next session, and we will understand debugger related information in that, and with in a practical way, and hope this help. And we will learn some other Linux based commands in that. Thank you very much.